All right, folks, today we're going to be taking the number 13 and converting it from decimal into binary. Now, there are two ways that we can go about doing this decimal to binary conversion. There's one way that PLTW likes you to learn. There's another way that I like to do it. They're very similar. They kind of follow the same principle, but one way works for some people, one way works better for others. Personally, I like my way a little more. I'm going to show you PLTW's way first. PLTW's way involves using divisions with remainders. So the first, and you're just always going to be taking your decimal number and dividing it by 2, and then using the different components that determine what your binary number is once you've done a series of divisions by 2. First thing we're going to do, we're going to take 13. We're going to divide 13 by 2. Now 13 divided by 2, 2 can go into 13 6 total times with a remainder of 1. Right, 2 times 6 is 12, plus 1 gives us 13. So what we're going to do is we're going to take that number 6 up there. We're going to divide that by 2. Well, 2 divided by 6, that gives us 3. And then we have a remainder of 0, right? 2 goes into 6 times. No remainders. Nothing's left over. All right, now we're going to take 3. We're going to take 3, divide 3 by 2. Well, 2 goes into 3 one time. There's a remainder of 1. All right, so 2 went into that, so we'll take 1. How many times does 2 go into 1? Well, 2 goes into 1 0 times. So once we get to a 0 in the top, we know we're done because we just dividing things 0 by 2 is going to do nothing for us forever. But that 2 divided by, that does give us a remainder, right? 2 goes into 1 0 times. The remainder is 1. This is actually where we're done, just about. Because right here, we actually have a binary number. It's just listed on the side right here in reverse order. We just start at the bottom and work our way over. We just do 1, 1, 0, 1. Now the one is what's called the one at the start that we started with is called our LSB. It's our least significant bit. This is a term you'll need to know. Now the one at the very bottom, our final one, that's our MSB. That's the most significant bit. All it means is that is the bit. This is the ones digit that is worth the most. This is the ones digit that's worth the least. So over here, remember, over here in base 2 world, that very first one is 2 to the 0, which is 1. The next one would be 2 to the 1, and that's a 0 attached to that. But that would be the decimal equivalent 4. Then we have our 2 to the 2. That's a 4, excuse me. The first one was a 2. And then we have our 2 to the 4. 3. You can tell it's been a long day at this point. That's our 8th place. Now, if we wanted to convert this back into decimal, let's just remember that all we would have to do is take 8 times 1 plus 4 times 1 plus 2 times 0 plus 1 times 1. So we have 8 plus 4 is 12 plus 1 is 13 again. Wrapping back to there. Now, that's the way that PLTW likes you to learn. I think it works pretty well, actually. And it's the more mathematical way to do it. It's probably the more efficient way to do this. But the way that I'm used to doing this, which results in just about the same thing, so we take our number in base 13, or in base 10, our number 13. Now I just go in and I just start writing out my binary powers. I'm basically doing the same thing. I'm just skipping all the successive divisions and kind of doing them in my head. So I'm just going to have my 2 to the 0. I'm going to remind myself that's a 1. My 2 to the 1, I'm going to remind myself that's a 2. 2 to the 2, 4. 2 to the 3, 8. 2 to the 4, 16. 2 to the 5, I won't need these last couple, but 2 to the 5, that's going to be our 32th place. I'm just going to start on the far left. I'm going to ask myself, how many times does 32 go into 13? Well, it goes in 0 times. How many times does 16 go into 13? 0 times. How many times does 8 go into 13? Well, 8 fits into 13. 8 fits into 13, all right? So I'm going to take 13 minus 8. 13 minus 8, that's going to leave me with 5. How many times does 4 go into 5? Well, 4 goes into 5 one time. So now we have a 1 left. 2 goes into 1 0 times, so we don't have a 2. And now 1 goes into 1 once, so we've got a 1 right there. I'm really doing the same thing, but just breaking it down and not taking the kind of asking myself, does this number fit in this number? Two different ways to do it. In the end, it comes out to be the same thing. Our number earlier when we converted it was the same thing in binary. I just didn't have the zeros in front of it. Those zeros don't matter. All right, thanks for watching. I hope this was helpful.